Right. And this is the vertical change over the horizontal change. Okay. So now what I'd like you to do is take a look at that table. So I have some stuff going on. Where would we find the x's and where would we find the y's?
If I have the left and the right,
Okay. So if I wanted to do the change in the y's and the change in the x's, let's just go and use the table to do that. So over here, this is the y's, right? So does it make sense to you that the change in the y's is over here, it's 40, and the change in the x's is 5? Okay. Let's keep going. What's the change in the y here? Plus 40. And what's the change in the x here? Plus 5. How about there? 120 to 160. Plus 40. Plus 5. Okay. So now let's record in the table the change in the y over the change in the x. The first thing we said was 40 over 5. How about the second set of differences? What was the change in the y? 40. What was the change in the x? 5. How about what's 40 divided by 5? And how about here? Change in the y is 40 over 5. Are they all the same? Yes, write a yes there. If they are all the same, the relationship is considered linear. If not, it's something else. Do you remember how we did quadratics and exponentials with ratios and second differences? Okay, that's what I mean by something else. We're not going to worry about those again right now. We're just focusing on linear. So, is this relationship linear then? Yes. And actually, the change in the y over the change in the x is called the what from above? What do we call that? The change in the y over the change in the x is called the slope. So what is the slope for this situation then? 8. Okay. So is this a linear relationship? The answer is yes. And the reason why is because the change in y divided by the change in x is the same. If it wasn't the same throughout the whole thing, it would not be linear. Okay. Well, now I'm asking you to do something different. Let's remember y equals mx plus b. Y equals mx plus b. We know one of these things. What do we know? M or b now? M. What is M? 8.
What is M and M?
Ooh, M and M. Thank you, Mr. Shelburne.
You're welcome.
So, would you agree then it's y equals 8x plus something, maybe? Does that make sense? Okay. Let's see what we have to do. What's the plus something? So, I'm going to go back up here, and I'm going to check. Would you put x in here? Put 5 in for x. Will you get 8 times 5, correct? Ooh, is that 40? Yes. Okay. Let's put 10 in. 8 times 10, is that 80? Yep. Yeah. It's looking like I don't need to add anything, huh? Alright, so this implies that the equation for this is just y equals 8x. So that has no y-intercept. Okay. So in general, from a table, how do I find the slope? What did we just learn? Riley? But how did we get the 8? How do, in a table? So, in general, if I want to find the slope in a table, I'm going to find the change in the y and the change in the x, and I'm going to divide them. And if I find that they are all the same, that is my slope. Okay, let's turn the page. Okay. Let's do the same thing again. So here's my table. Let's see if we can find the slope. If you need a calculator out, you can get a calculator out. I did the first one for you. 50 minus 30 is plus 18. What's 10 minus 0? 10. What's 68 minus 50? How do I get from 50 up to 68? Add 18. How do I get from 10 up to 20? Add 10. How do I get from 68 up to 86? Add 18. How about from 20 to 30? Add 10. Is it looking like it's linear? Okay, let's just make sure. 86 to 104 is plus 18 plus 10. Okay, so the change in the y over the change in the x is 18 over 10 for the first, the second, the third, and the fourth. So, also, what is 18 divided by 10? 1.8. So you guys tell me then. These were all the same, correct? If they're all the same, we say that the relationship is linear. So is this relationship linear? Yes. Why? Because, don't say it's the same, because I don't know what it is. Because the change in y divided by change in x is the same. Okay. So 1.8 is called the what? The slope. So earlier on we said then, if the relationship is considered linear, it can be written in the form y equals mx plus b, and I know the m. The m is what? 1.8. Now in the last table we didn't have to add on a b. Let's check and see if these work. Okay. So I'm going to go to the first number, and I'm going to do 1.8 times 0, which is what? Uh-oh, is that what I see right there? No. What would I have to add to 0 to get a 32, though? 32. Okay, let's check this one. Let's do 1.8 times 10. I do not get 50, right? But if I added 32, do I get 50? Ah, let's do it one more time. It looks to me like b is 32. Is that what you're thinking too? Okay, let's put 1.8 times 20 and add on 32. Okay, so what's our equation then? 1.8x plus 32. This was it. We had to add a 32 here. We had to add a 32 here. We have to add a 32. Okay, but that's not, you can't get that from the table though. You would have had to plug it into 1.8, yeah, and figure out that it's 32. You could take what's in the table and subtract what you got in your calculator, is that what you mean? You could do that, yeah. Okay. Here's what I want you guys to do right now. Would you find for me the change in the height over the change in that? And see if you can fill out this table by yourself.